Free audio post-production by alphonic.com.
Just take the one unit, pop it out of your car, set it up, and literally, as long as you're pointing up at the air, it's going to track whatever is up there. We have a very nice field of view, 100 degrees by 70. So it gives you a very large operational area to be able to detect and track.
You're listening to the Drone Radio Show podcast, the show about drones and the people who use them for business, fun, and research. Hosted by Randy Goers.
Hello, everyone. This is Randy Goers, and welcome to the Drone Radio Show podcast, episode 438. Can a small portable radar system effectively and safely scale drone operations? For that question, we head to San Francisco to speak with DeMatteis, Chief Revenue Officer at MatrixSpace. MatrixSpace is a leading technology company specializing in advanced radar systems that deliver real-time situational awareness for uncrewed and autonomous systems. Their compact, lightweight radars offer precise detection and tracking, making them ideal for drones, advanced air mobility, public safety, and critical infrastructure. By integrating cutting-edge radar with AI, MatrixSpace enables safe, efficient operations in complex and dynamic airspace. Lori plays a key role at MatrixSpace, leading sales and go-to-market strategies across various industries and regions. She has a strong track record of driving revenue growth for emerging technologies, taking companies public or guiding them through mergers. Prior to MatrixSpace, she served as Global Vice President of Customer Success, Sales, and Marketing at Iris Automation, and held leadership positions at GE, Oracle, Emerson, Honeywell, and Lavin Holdings. Her expertise spans hardware, software, and networking. As beyond visual line-of-sight operations expand, the demand for scalable, precise, detect-and-avoid solutions grows. MatrixSpace portable radar systems are designed to meet that need. The company recently announced partnerships with AAM provider Skyway and public safety leader Adventure to support airspace awareness and safety. Lori works closely with these and other UAS AAM partners to help navigate the evolving landscape of airspace management. In this episode of the Drone Radio Show, Lori talks about MatrixSpace, their radar technology, and how organizations are integrating these tools into their airspace operations. But before we hear from Lori, I want to stress that your support is the heartbeat of my podcast. Every episode is crafted with you in mind, and your generous donations ensure I can keep delivering the content you love. Whether it's a price of a coffee or a more substantial contribution, every bit helps to defray the cost of production. Donate today and be a vital part of the podcast's continued journey to greatness. To donate, go to droneradioshow.com/donate. And if you can, please subscribe to the podcast on your favorite platform and leave a nice review and rating. It really helps improve the podcast ranking among the many thousands of active podcasts today. And by the way, if you have a great story about the use of drones that you'd like to share in a podcast, contact me at randy@droneradioshow.com. So let's learn how MatrixSpace is helping to advance safe, scalable, beyond visual line-of-sight operations with DeMatteis. Let's pick up the interview where I asked Lori to introduce herself.
Hello, I'm DeMatteis. I am Chief Revenue Officer of MatrixSpace.
Lori, let's start with the basics. What does MatrixSpace do?
Well, we like to talk about ourselves as an AI software-defined company. The hardware that this AI runs on is our radars, and they're very unique in not only their size, but also their weight and power. So you can literally run one of our radars from the back of your car, set it up, turn it on as long as you appropriately have a site license, and leave it there with a battery or a solar panel. It's just absolutely amazing. You could have it run forever. You can go collect the data afterwards. You do not need to have it connected to anything, although you can, and of course it operates that way. But it is very flexible for use in our military as well as for people that need to be out checking on different areas, being able to move operations to different places depending on what they're doing.
Are the radar systems mainly designed for the drone industry, or do they have a broader application?
We designed it to actually be on drones, so we have that capability, but we also very much focused on the ground. And from the ground perspective, it's really the use cases are endless. When you think about it for security, outdoor security, I want to make it very clear that this is all being used outdoors. We also have perimeter security. We have air security, low air surveillance security, as well as being able to support some ground work as far as movement on the various endpoints, if you will.
For those who may not be familiar, can you explain what detect and avoid means in the drone world?
Well, detect and avoid is a lot of times people will hear it as drone as first responder. They'll hear it as BV loss, beyond visual line of sight. But the whole purpose is just what it says. It's detect and then make sure you avoid something that might be coming at you, particularly when you're flying an unmanned system. So what that enables you to do is take that unmanned system and make a decision of, I need to move it to this direction. I may to take it lower. I don't want to take off at all because there's a helicopter flying above me. There could be a small Cessna coming in. So those attributes or those applications are very broad. They can be everything from a first responder trying to respond to a scene, check out an accident, find a missing person. It could be somebody trying to do a delivery in the airspace. So they want to be able to fly from point A to point B safely. It could be somebody that is just doing rail surveillance, in other words, making sure the rail line and the rail tracks to support a train that might be coming 10 minutes, 20 minutes later, being able to make sure that everything will be safe for that train. You have utility inspections, you have pipeline inspections. There's a variety of use cases. Ports, being able to fly a drone to maybe a ship that is out, haven't been able to come into port yet, but is there. They can start to deliver supplies to it. They can start to deliver all the paperwork necessary for it to enter. So that makes it a faster turnaround because ships lose money when they're in port. So how do you speed up the turnaround while they're docked at that port? So there's a lot of different attributes that happen with what we call detect and avoid. It's all to enable flight safely.
What makes for an effective detect and avoid system? What key elements are needed?
Well, to make a great system, what you have to have is obviously the unmanned system that's flying. That's number one. You have to understand your use case because various use cases need different things. And then you need a sensor that will be able to detect what it is as it's flying to make sure that it's flying safely. In other words, being able to fly beyond visual line of sight. So beyond your line of sight, so you don't have to have observers at every point that you're flying. Now you're able to fly as long as your drone can fly, technically. So what do you need for that? You need a really strong sensor, either on the ground or on the plane itself, or both places. It just really depends on how, like I said, that use case. So the first thing is a use case to determine what partners or systems you need to combine. With the fact of a great sensor, you need to look at the technology to enable both daytime and nighttime. If that's the operation going on for you, and again, it goes back to what is the use case, then you're going to need to have a sensor and technology that supports that use case day, night, making sure that you are able to go as far as that item is flying, as far as it's going. Those are some things that make a great sensor. I also like to look at it from the software layer. What I think makes a great sensor is being able to give the data and intelligence to the processing layer to give it as much information to make the decisions as smartly as possible. And so that includes offering the data and the intelligence from that sensor and that sensor capability. And so is that sensor a dumb sensor that is just sort of reporting you can't get the data and the details necessary to make decisions around it? because like I said, I think that's a game changer for our industry. So what MatrixSpace does that I think is very unique is we have some very key intelligence. So our information is not just a basic picture that you're looking at and have to make decisions around that picture. Our picture has smarts behind it. So we can give detailed information of what we're seeing, how we're seeing it, how far we're tracking it, how long it's been in that plane, and where we expect it to go, and the confidence behind what it is. So those are some attributes that up-level a system, if you will, and up-level a sensor. So I think we're getting into the next generation of sensor technology. It's not just like on and off. It's very much intelligence all the way through that process.
How do MatrixSpace radars support detect and avoid capabilities for drone and air mobility providers?
Well, first of all, we are really excited because that's what we're specializing on. The company has been working for years on this AI machine learning intelligence. And everybody has a huge background in IoT. So think about this as the next generation of IoT. And instead of being focused on sensors that are performing within machinery or sensors that are performing on factories and things like that, which we've always thought about for IoT. Now we've got sensors that are focusing on the air and on air performance and agility. So what we're doing is we're taking that intelligence, we're removing a lot of the clutter that you typically would see, for example, in a radar. By virtue, radars detect movement, but is that movement necessary for the application that we're working on? And so we work with our customers to fine tune exactly and precisely what they're looking for. And then with that fine tuning, we give them the attributes and that information. So like I mentioned earlier, that information could be the classification, that information could be the direction, the velocity, the timing. All of these integral elements go into what we're supplying to our end users.
Can you explain how the radar data is used? Does it go directly into the drone system, or does the radar itself help make decisions?
No, what we do is, we're ground-based. Even if we were on board, we're not making those decisions. Those decisions like to be left at the end of the end users. So we're doing that detect and alerting. They make the decision on how they're going to do that avoidance. But when our detection and alerting, it could be we're alerting into the C2 link on that unmanned system, or we're alerting on the ground to that, what I like to call the presentation layer. Now, we are so simple in how we integrate that we are integrated with a number of key companies and vendors that our customers use. And a lot of that integration depends on industry segment. For example, if you're working with a ghost robotic dog, one of our partners is Area Security, and they're doing security for very large companies as well as for DoD and state security. And many countries, not only just here in the US. And so we're working with them and their layer they do a lot of intelligence as far as process and workflows that move through the system as well. So we give them the information that says, alert, something isn't normal. They then take that and decide, okay, let's say somebody's hit a barrier. No problem. That's just a fence line. Warning, you're near our fence. Now they keep coming in and coming in. They will give you, as the operator, decisions to take because of those things that are happening. And then they, whether it's somebody's going to run out or they're going to send up a drone or whatever's going to happen, depends on A, what they see, and B, how they are approaching things, and if there's multiple people or multiple things. Those are the kinds of information sets that we give back to our partners so they can create that presentation layer and those workflows, as I just mentioned, and those processes. Now, when you're talking about a drone as first responder, there's a number of programs that integrate both the drone technology in addition to the sensor technology and bring everything together. And so it's really a combination that helps make that intelligence. It's no longer just a single system. It is a system of systems combined to do deep intelligence so you have the right actions at the right time at the right place.
Is that where AI comes in?
Yes, very much so. Very much so. And like I said, it really depends on the use case. Is this a border use case? Do we have drones coming in? Do we have something else coming in? Do we have missiles coming in? Right? That's where you have various systems in addition to our radar that can see visually and make some determinations and add into the increase of certainty. You have the ghost robotic dog that I just talked about. That dog is out looking at different things. It's seeing maybe movement in a place. It might be able to see movement behind train, or I should say some kind of objects. So you can be able to make decisions based on what it might be seeing and have something else behind it for security. You've got a drone as first responder. It's flying up. It doesn't want to hit a helicopter. It doesn't want to hit a Cessna that's low flying in, maybe coming into an airport. So you've got safety in our cities. You've got intelligence on critical infrastructure. What's flying above me every night? We would be very surprised to know what is really taking place in our skies, because it's no longer end-to-end protection of just our shores. Our shores do not keep us safe any longer. And so we need to be able to have protection on our key assets and understanding what's going on. So then we can make decisions on how we want to protect those assets.
MatrixSpace recently partnered with Skyway and Adventure for advanced air mobility and public safety. Can you summarize what those partnerships are about and the role of MatrixSpace?
So from a standpoint of Skyways, we're working with them hand in hand to support the work on vertiports. And so whether that could be for medical deliveries, whether that could be for package deliveries, whether that could be for X to enable air taxis in the future, they are one of the leading providers, the ability to create vertical ports where people can go and something can happen around that. So do you have mid-level package delivery? Do you have assembly? Do you want to do flying people, flying taxis? Do we want to do just sending of documents like I just talked about, boats, right? And ports. So they are putting out a product that enables the management of those across multiple places and combining that information set in different areas. It could be a whole different state. It could be a state network system. We hear about air corridors a lot in different states. They are supporting those efforts and that action. Now, from a standpoint of Adventure, they are very, very strong and big in the DFR market, in critical infrastructure security. And so we work side by side with them in their drone-in-the-box solution to enable safe flight of those drones for whatever the use case could be.
What are some of the biggest challenges when developing radar tech for drones and air mobility?
I think things have really changed in the last year and a half. The FAA and the FCC has really come together to support the industry. And so obviously everybody needs to, especially if it's radar technology, you need to have approval to even operate and transmit using your radar. And so we have had super support from our FCC and from the military contingent NCTA within that. And then from a standpoint of having site licenses, we've had no problem with the FCC. It's been a very simple process. And we are very blessed, honestly, to be able to have such a great team and working environment. And the same with the FAA. I think the goal of the FAA is to keep our airspace safe and not to have what just happened over Washington, D.C. ever again. Although it wasn't a drone on a plane, it was a plane on a plane crash. We cannot rely just on traditional responder technology. The ADS-B did not go off. Unfortunately, it did not work. And so can we have other attributes that can notify and inform and make sure that there is never a collision of a drone onto a general aviation aircraft or drone onto a drone? And that's what the FAA is working and responsible for. And so we have great support of them of being able to facilitate use cases to enable the technology so we can have use of this and keep adopting and making sure that, people get to do higher level tasks, but yet keep America moving quickly. And that's one of the things that FAA is very focused on. So it's just been a really nice, 4 or 5 years ago, it was very difficult. Today, following a very prescribed process enables you to accelerate.
Are there industry standards or benchmarks you have to design around, especially with so many different companies and approaches?
Well, there's a standard as far as how it transmits. We're very fortunate in the bandwidth what we operate in, which is 24/45 to 24/65. First of all, you have to make sure that what you're saying and you're transmitting is not going to harm somebody, right? We're, like I mentioned a second ago, we have very low transmission. I mean, less than a cell phone. But that's one of the things that the FAA or the FCC wants to check. That's you go through very stringent laboratory testing. I mean, we're very different operation with our unit that just flips up in 5 minutes than a big unit that you might see at an airport, right? Those waving radars that are at the end of runways that you see on a plane as you're leaving. Those transmit a lot of energy. Those have very different license structures and very different attributes than something as small and nimble as our radar system. And to the FCC's credit, they understand that. So there are different rules and different paths depending on what it is you're certifying.
How would you describe the current adoption of radar systems by major infrastructure players like airports, critical assets, and so on? Are they jumping in, or is there still hesitation?
I think the catalyst point in the United States was November on Ocean County and the reports coming out of Ocean County and a little bit of a New York. And so you're starting to see cities look at it from a standpoint of, I have a port here. I want to know if people are flying over my port. You have cities saying, I want to be able to fly my drone as first responder program and be able to support, let's say a crime scene faster. So, for example, the horrible thing that happened in New York City, could they have been able to launch a drone and follow him so that we wouldn't have been waiting 2 or 3 days to find the perpetrator that had done the shooting? So there's a lot of things that can happen good for our public, finding lost people. So, there's applications within cities. And so, yes, cities are starting to step up and realize this is how you keep our city safe. And our citizens are asking for it as well. This is not something that's fearful. Instead, it's something that I can see the benefit. Let's get it moving here. So you're starting to see that, whereas, a year ago, year and a half ago, people were still early adopters. Now it's becoming much, much more mainstream and much, much more expected within communities. And it's not just large communities, it's mid-sized communities as well.
Are your radar systems also used in counter-drone scenarios?
Like I said, people are aware, what is flying above me? What is coming around my fence line? All of those are attributes that we work with. We work with some of the largest partners around counter technology. Now, in the United States, counter technology means I want to know where that person is coming from. Where could that person be located that flew that drone? Counter technology could be as much as, and this is some of the things that we're working with police on, what is happening in our airports and our small airports. So it just really depends on what it is and the attributes. In our prisons, for example, large needs in our prisons because you have a lot of drones that drop in paraphernalia and embargoed items that are not legitimate. So can we stop that from happening? You bet prisons can. They can have, be notified that something is coming into the prison itself and have somebody get out there before it comes in. You can be notified that it's coming and you can see where somebody might be setting them off and be able to go and either arrest or talk to that person depending on what's going on, and it'd be appropriate for that situation. So there's a lot of different nuances happening from a counter standpoint. Do we want to make sure that drones don't come back again in some of the football games and some of the key rallies that are happening? Yes, you can actually, give the information intelligence so the action can be taken. Are we going to shoot down that drone? And like I said, we don't do that in the United States, but in other countries you can. So what is the appropriate action that the regulatory bodies are allowing in a given locale or given situation, and then being able to address that? So we're a sensor of sensors in that kind of attribute. We can showcase where it's coming from, for how long it's been coming from that area. And then, is it transmitting or not? Is it friendly or foe? So it just depends.
Can the radar detect the drone that's turned on but not moving? Or does it really need to be airborne?
We need to have something moving, right? But what's very interesting in that question is that we did a defense challenge, which was, when can a radar pick up a moving object that's very tiny, very, very small? In this case, it's 12 inches, less than 12 inches by 18 inches. we were able to pick up that object at 300 feet and then be able to track that small object all the way out to 900 feet in the air in altitude. So not bad given the small form factor that we operate under and the low cost to be able to do it. And that's another thing that's changed the market. Radar systems used to be the size of a bathroom and $1 million and $1 million in infrastructure, right? Then they got a little bit less expensive. But having something the size of your cell phone that you can pop out of a trunk and, you think about the sheriffs and having it in the back of every police car or sheriff car and being able to set it up in somebody's yard that's saying that something's flying over or some kind of piece of critical infrastructure, leave it there for a couple of days and then come back and pick it up because, we store the information right there inside the unit and process in the unit so it doesn't have to transmit anywhere. So it can be just standalone and then come back and research it. I mean, those things have never, ever been there. So this is, like I said, I get really excited because it's really the next generation of where everything can go and the capability. But to your question, we can track something as long as it's moving a little bit. I mean, as small as a golf ball.
You mentioned portability. Can a single unit really be deployed quickly and still give full sky coverage?
Just take the one unit, pop it out of your car, set it up, and you wouldn't even have to attach to it. So you don't even have to worry about that comms. But if you wanted to, you could attach an iPad to it or your local computer. So just attach it and you could be watching, right? But the point is yes, you can throw it out of your car, pick it up, set it up in 5 minutes, not have to have any infrastructure, not have to pay a dime for that. And literally, as long as you're pointing up at the air, it's going to track whatever is up there. We have a very nice field of view, 100 degrees by 70. So it gives you a very large operational area to be able to detect and track.
What's a standout project MatrixSpace has worked on? Take us behind the scenes. What was involved and what challenges were faced?
Well, I think the toughest problem we have to solve as an industry, right, not just us alone, is how do we want to integrate the information, right? We have an amazing, amazing information. We have a relationship with a vendor that enables us to do a lot of computing at the edge and then be able to bring back that computing into storage and be able to keep that for being able then to detail exactly what's going on, like every day at 2 a.m. now we're seeing this pattern and be able to start to take patterns and just figure out we've got some very serious problems here, X or Y, because you're able to do that where we have computational analysis that hasn't been able to be done. So I don't think that the industry, it's no longer just about the sensor or the hardware. Like I mentioned, it's about that application layer and about that intelligence. So the hardest thing is doing some of the testing on some of the objects to get very detailed and very specific as to if this is X or is this Y. And so that's what we spend a lot of our time now doing and working on is making sure we have robust information and data to enable to do those calculations for our customers and give them assurance about it.
How did you get involved in the drone industry? What drew you to the space?
So I am like an old timer, even though I've been really working on this for about 6.5, 7 years almost now. And so it's very young in time of many people, but from a standpoint of just the drone focused, I've been here for that long. Before I was with a company earlier than MatrixSpace called Iris Automation. Now, from a standpoint of my experience, though, it's very deep. And so I think what's important is like I mentioned, this is not just a hardware play, it's a software play, but you also brought out communications. So I have a comms background from my early work that I did with AT&T and Bell Labs. Then I have work from all the software layer. And I've been working on IoT for probably 20 years in first generation IoT, all the way up to where we see it now. So it's been really fun to work on this evolution and this journey. And I mentioned the software layer. I've been doing software for many years and some of the biggest software systems in the world, with some of the biggest providers in the world, being able to put out in the enterprise plays as also military plays with software. So that's what it really takes now is all three of those layers to be able to bring those together to combine what's going on at that edge.
Reflecting on your 7 years in the field, what's the biggest lesson you've learned about the industry?
I think that the drone industry is now starting to come, right? Earlier in the early, it was really a little bit early. It was when people were like, oh my God, these flying insects are going to hit my yard. They're going to do all these things, right? Now it's about of how fast can you get it to me? How fast can you protect us? So there's been a whole change in security and the adoption of surveillance. And now you're starting to see finally the whole evolution of where AAM can be with air taxi and how it can support. We just don't have enough roads. You cannot build enough roads fast enough. So you have to go somewhere else. And we have some amazing technology on that front that will enable these routes and enable the autonomous work. And so you're starting to see the initial generation of that. So I think this industry is a very bold, very brilliant industry that is just hitting the very start. I'm anxious to see where it goes the next 30 years, the next 50 years, because it's going to be, I think, accelerating. I don't know that we've even touched all the use cases and everywhere it can go yet. We're definitely in that first part of the history. I liken it almost to the old Model T. Get this, as we're in the very first part of that Model T, and now look at what we have with cars. We have autonomous cars. Who would ever thought that old Model T was going to be an autonomous car today? And so I really think about that's where we are with drones. I mean, we're a lot of manual work. A lot of hard work has to go in. But I think that will change as we keep to going through, and autonomy will start to keep piling through. And like I said, I just think it's super exciting.
What's next for MatrixSpace? What should we keep an eye on in the months ahead?
A number of announcements, very, very exciting announcements in Q2. We're dual. So, we work with both our federal government, we work with the DoD, as well as in our communities. So we have a lot of exciting things happening. I can't wait, honestly. We're going to announce some very major partnerships in addition to some major customers. And so it's going to be a lot of fun. So I would encourage your viewers and everybody to stay tuned to what's happening here at MatrixSpace in Q2.
On the civilian side, what type of organizations use MatrixSpace systems? You mentioned law enforcement. Any others?
We work with railroads, we work with small towns, we work with big cities, we work with police teams, we work with, and of course, that's the first responder community. We're working with colleges, we're working with universities, we're working with, you mentioned skyways. I mean, that's all ports, vertiports, I should say. I mean, you name it, people are asking what's coming up to me and what's above me. And so that's what we're working with.
Do organizations typically come straight to MatrixSpace? Or are you usually working as a part of a larger ecosystem with other partners?
Sometimes they call us directly because we have a very good brand reputation and we have some very strong leadership. David Cameron has been known in the industry for years. In fact, it was myself and David and another gentleman, Brandon Carr, that wrote the first waiver in the United States ever for the technology, for the first responder market. So, people call us and say, help, how do we start? How do we kick off this? What do we do? How do we make sure that the FAA is pleased? How do we make sure that, our end users are pleased? So it can be a partner, it can come direct, there's many ways. But the important thing is that people are starting to take the journey and you don't want to get left behind. And the further you wait, the more technology adoption you're going to have to take and the harder it's going to be. So honestly, what I've been telling people is the timing is now. A couple of years ago was a little bit early, but now there's paved paths. There's a way of getting assurance. There's a way of getting an ROI return. And so take advantage of that.
And for my final question, Lori, what message would you like to leave regarding the future of the drone industry?
Well, I think it's just not the drone industry. I think it's the future of autonomous. Whether it's autonomous flight, autonomous vehicles on the ground, it's a future of autonomy. And I think that the whole thing is for students and for individuals that want to learn, make sure you stay in your math and science because it is about the software layer. And then from a standpoint of where is it going, like I mentioned, I think we're in the Model T a little bit advanced in Model T, but we're in that very early stages where we're going to start to see some very, very unique and very exciting things happen. Even around the Olympics, people are talking about how can we take care of transport with Olympics. And so they're looking at having some autonomous flight for the Olympics. So, because the LA is so congested. And at least at the worst case, it's just to being able to fly drones, flying autonomous vehicles to be able to move information and paperwork and things like that. So I think that people just need to be assured that this isn't spying on them. There is no information collected from a radar, right? We don't have characteristics. All we're collecting is movement. We can tell you, is that big movement? Is that small movement? But, we're not going to be able to say that that's a white car with 3 people in it or anything like that. We can't ID. But what we can do is give information that allows for better decisions and make sure that nothing could ever happen that would be, an error, to prevent the errors to facilitate the future.
That's it for episode 438 of the Drone Radio Show. I hope you enjoyed hearing from Lori DeMatteis of MatrixSpace. I want to thank Lori for taking the time to speak with me. If you want to learn more about MatrixSpace or want to connect with Lori, check out the webpage at MatrixSpace.com. If you like the Drone Radio Show, then please subscribe and share. Write a glowing review. And if you're able, donate to keep the podcast going. Go to DroneRadioShow.com/donate. And thanks for listening. Your support means a lot to me, and I hope you'll listen to more episodes of the Drone Radio Show podcast to hear how others are using drones for business, fun, and research. For the Drone Radio Show, I'm Randy Gores.
This has been the Drone Radio Show podcast. More information on today's show can be found on our website at www.droneradioshow.com. If you're using drone technology for business, fun, or research and would like to share your experience on the show, please visit our website and fill out a guest appearance application. And don't forget to follow us on your favorite social media channels.
Free audio post-production by alphonic.com.